If we want to train or even just use very large AI models, we oftentimes run up against the limitations of our hardware. Most GPUs don't have enough VRAM to run the latest LLMs or models like Stable Diffusion XL. However, sometimes it's possible to combine two smaller GPUs and their combined VRAM is enough for the task. That is exactly what we're going to talk about in this video today. How can we utilize multiple GPUs to run large AI models? So let us get right into it. Alright, so we're going to learn how to use multiple GPUs in order to run large AI models in this video today. Now you might be asking yourself, why would I need to know this? Who on earth has two GPUs in their computer? And of course, this is not about your personal computer. This is about having access to two GPUs on a server. For example, if you're renting a server with multiple GPUs, or if your school or your university provides you access to that, or if maybe your employer provides you with access to that, and you want to run something that takes, let's say, 30, 32, 34, 38 gigabytes of VRAM, but you only have two GPUs that have 24 gigabytes each. How do you do that? Because combined, the VRAM would actually be enough to run the model, but you can't do it because you cannot fit the model on a single GPU. In this case, what you can do is you can split the model across multiple GPUs and still get the task done, even though you don't have a single GPU with enough VRAM. This is what we're going to learn about in this video today. And for this, we're going to use an example, which is Stable Diffusion XL. This is a model that if you set the resolution to be high enough, it's going to take up quite a lot of VRAM. I think if you go with 2048 times 2048, you will not be able to fit this on a single 24 gigabyte GPU. So we're going to need multiple GPUs to do that. And this is going to be our example today. Now, the plan for this video today is to briefly code out the process of loading and using Stable Diffusion XL in Python on any system. I'm not going to be able to run it on my own system because if we take a look at my NVIDIA SMI output, we have here on the system 8 gigabytes of RAM. That's not enough to run any resolution using Stable Diffusion XL. So I'm not going to be able to do that locally, but we're going to write the code locally just to see what it looks like. It's quite simple and quite short. Then we're going to take that, we're going to deploy it to a serverless endpoint that has access to a single GPU. We're going to see that it doesn't have enough VRAM if it only has 24 gigabytes. And then we're going to do the same thing with two GPUs to show that we can actually split the load across two GPUs, and we're going to see how to do that. So I want to start right away with coding the example locally. For that, we're going to open up a command line. I'm going to navigate to my working directory, and I'm going to open up a file main.py. And here now we're going to write down the pretty simple and minimalistic code. It's import PyTorch, then from diffusers, we want to import the Stable Diffusion XL pipeline. Then we need to create an instance of it by saying pipe is equal to Stable Diffusion XL pipeline. We're going to provide the path or the identifier for the repository, so stability AI / stable diffusion XL base 1.0. Then we're going to also specify the precision, the floating point precision. If we use half precision, we're going to be able to save some memory. So we're going to say torch underscore dtype is equal to torch.float16. This is half precision. And that is our pipeline. Now, if we want to generate an image based on a prompt, we just have to say image is equal, or actually, sorry, we need to say with torch.inference mode. Image is equal to pipe, and we apply that pipe onto a prompt. For example, a futuristic skyline at night. Then we're going to specify some parameters. For example, the width could be 512 pixels. The height could be 512 pixels. Then we want to also specify the number of inference steps. So how often do we denoise the image? I'm going to go with 30 here, which is a good value. And then we're also going to choose the guidance scale or set the guidance scale. Basically, this is a value that determines how much the model pays attention to the prompt or to how strict the model interprets the prompt. So if you set this to 10, you're going to have probably very high quality images, but they're not going to be very creative. They're going to be pretty monotonous. Whereas if you set this to a lower value, it's going to be more creative. If the value is too low, it's going to be very chaotic and it's not going to be really based on the prompt at all. So a good value here, the default value is 7.5. We're going to use that here. By doing that, the result here is going to be an object that we can get images from, and the first image is going to be our generated image. So we apply the pipe onto the prompt with these parameters, then we access the images object, we get the first element out of that. That is going to be our image. The only thing that we need to do now is image, save, and then whatever you want to call this, output.png or whatever. That is going to be our process. So you can see the code is not very complicated. The code is very short, but if you want to run this on multiple GPUs, if you want to run this on a serverless endpoint, you need to change some stuff. And we're also going to add some stuff to make sure that we actually use 2 different GPUs and both of them are actually not just present, but also used. So for the deployment, what we're going to do is we're going to use a platform called beam.cloud. They're actually sponsoring this video, but of course there's no need to click away from this video because you can follow along for free. If you sign up for Beam, you're going to get free credits that you can use. Of course, at some point, if you want to continue to use Beam over time, you're going to have to pay, but to follow along with this tutorial, to play around with Beam, you don't need to invest money. You can just sign up, you're going to get free credits, and you're going to be able to work on the platform. So what we're going to do here is we're going to create an account, and then we're going to follow some very basic steps to deploy our code onto a serverless endpoint that has access to multiple GPUs. And first of all, we're going to also try with a single GPU. So create an account, log in, and then you want to go to this quick start section. By the way, you will find links to all these in the description down below. All we have to do here, very simple, is we have to create a virtual environment. We have to install the Beam client using pip, and then we just have to define an endpoint like this. You have some function that does something. In this case, this is going to execute our code. We need to annotate that function with an endpoint where we provide a name and some hardware requirements, maybe also some packages that we need. And then we just deploy and we're done. We can send requests to the endpoint and it's going to run our models if this is a GPU endpoint on GPUs. So here we have also a section on GPU acceleration. You can see it's quite simple. You have the code and you have the endpoint GPU. And if you want to use multiple GPUs, you have endpoint GPU, GPU count 2. So quite simple, nothing too complicated. So let's go ahead and follow the steps. I already have an account, so I have to click on get started to get to my account. What you want to do is you want to go to settings, you want to go to API keys, and you want to create an API key. In my case here, I already have one. So I'm going to take this token, I'm going to copy it, and then I'm going to follow this quick start instruction here, or these quick start instructions. So we're going to start by navigating again to the coding directory. Here now I'm going to say python 3-m venv.venv. We're just creating a virtual environment. And then we're going to immediately activate it by saying source and then .venv/bin activate. This is going to create and automatically activate an environment. And now we want to register the API token. For this, we're going to use a Beam client. We're going to say pip install beam-client. And then we're going to run beam configure default token. So we're going to set our access token for this Beam client so that it knows what it has to use for authentication. So this now installs the client. Once this is done, I'm going to clear. I'm going to say beam configure default -- token. And now I'm going to move this briefly to my second screen just to enter the token so that I don't have to show it in the video. Now it asks me if I want to override the default context. I'm going to say yes. Then I'm going to clear my command line and I'm going to get it back to the screen here so that I didn't show my key. So now we have the key configured. Now the Beam client is authenticated or knows how to authenticate itself with my account. And all I have to do now is I have to take the code that we wrote and I have to turn it into an endpoint. And in particular, I want to turn it into a GPU endpoint. So what I'm going to do is the following. I'm going to create a new file, app.py, and this file now is going to start by importing from Beam, endpoint, and image. Now, part of the code is going to be what we already had before. So I'm going to copy all of this here, and we're going to reuse that, but in a different way. So I'm going to paste this down here. We're going to, of course, also import Torch. We're going to import from Diffuser's Stable Diffusion XL pipeline. We're also going to import some core Python stuff. So we're going to import from IO bytes IO. Then also import base64. This is all core Python. And I think besides that, we're not going to really need much more. The reason we do this now is because we need to take the string that we're going to get as a JSON object. So we always get a JSON object. So we're going to have the image as an encoded string. So it's going to be the image encoded as a string. And we need to take that, we need to decode it, and we need to have the bytes, and we need to then write these bytes to a file. That's the basic idea. So this is going to be the general logic. I'm going to move this down here a little bit, and now we're going to define our endpoint. Our endpoint is going to be an annotation, so a decorator, and we're going to define, first of all, the GPU that we want to use. Now, we cannot use just any GPU. We can use the GPUs that are provided here. By the way, if you didn't see that, I am also using the trial credit, so I don't have a special account here where I got provided with some tokens or anything. So you can actually do the exact same thing. You can go and get free trial credits here on Beam. You don't have to be sponsored or anything like that. You can just sign up and get these free credits. And then you can choose one of these GPUs. I'm going to go with the A10G because it has 24 gigabytes. So we're going to assume I have, first of all, one of those. So I'm not going to even provide a GPU count, or I think I don't have to provide explicitly if I just use one. So that should work out of the box. And I'm going to also provide the name. The name is going to be SDXL tutorial. So Stable Diffusion XL tutorial. And I also want to provide the image here. The image is going to be equal to, let me just move this to another screen. And let me close some stuff on my second screen so I can read it better. The image is going to be the image for containerization. So we're going to actually deploy a container. For that, we need to say we want to use image, but we also want to add some Python packages to it. And these Python packages are basically the dependencies. These are going to be, in our case, torch. It's going to be diffusers. It's going to be transformers. Now, I'm not sure if we need all of them. While preparing the code, I added all of them. I'm not sure if every single one of them is necessary. So we have transformers, accelerate, safe tensors, we have pillow, and we have NumPy. But I think it's better to have more than less, because if you don't have all the dependencies that are necessary, it's not going to work. And this is now just the annotation for a handler function. And this handler function is going to get as input some parameter. In our case, it's going to be a prompt. The prompt is going to be a string. And the default is going to be, let's say, a skyline at night. Something very simple. That's going to be the default if we don't provide anything specific. And then we're going to say, first of all, I don't just want to run the code. I don't just want to generate the image, get it, and that's it. I also want to make sure how, or not make sure, in this case now, since I'm using one GPU, I want to know how much memory was used, and I want to know, in the case of two GPUs, how many GPUs were actually utilized. So what I'm going to start with here is I'm going to say if not torch.CUDA is available, I want to immediately return the information that I don't have a GPU that I can use. So I'm going to return error. I'm going to say no GPU available. That's a simple case. Otherwise, I want to count how many GPUs I have. So num GPUs is going to be equal to torch CUDA dot device count. This is only going to give me the available GPUs. So this is only the number of GPUs that I can use. Doesn't mean that I do use them with my code. And then what I want to do is for each of those GPUs, I want to measure the peak usage. So what was the peak memory status of that particular GPU? Now, the problem is that this is not necessarily always reset to 0. So what we want to do is for each GPU, we want to reset that state. And then we want to track it from scratch, basically. So we're going to say for I in range num GPUs, we want to switch to that GPU. So with torch.CUDA.device I, we're switching to the first device, to the second device, however many GPUs we have. And then for that GPU, we're going to say torch CUDA reset peak memory stats. So this resets everything so that we can measure it from scratch. And then we're going to run our code. So then we're going to run our stable diffusion pipeline. We're going to define it. We're going to run it. I'm going to just indent this here. For now, we're going to leave this part the same because we only have one GPU. We're going to also do the inference, but now we're not just going to say image safe because we want to actually return the image. We want to actually say, I think I made a mistake when I explained that. Of course, we're not decoding the image here, we're encoding the image. So we actually want to send the image as a string, encode it as a string. So this is why we do it. We just have to decode it when we get it, when we receive it. But in the case of the serverless endpoint, we of course need to take the image, encode it as a string, and send it to the user as part of the JSON object. So we're going to say buffered is equals to bytes IO. Then we're going to say image save. We want to save it to buffered, the format being PNG. And now we want to take that and turn it into a base64 encoded string. So image string is going to be equal to base64 dot b64 encode. And we're going to get the image from buffered. And we're going to encode this. We're going to decode UTF-8. So that is going to be the image string that we're going to send to the client that is sending the request or the prompt. And now after this has happened, so here is where the magic happens. So here we actually use the model and we actually do all the GPU work. Afterwards, I want to say peak underscore GPU underscore memory underscore info is going to be an empty dictionary. And now for I in range number of GPUs, I want to go through all the GPUs. I want to select them with torch.cuda.device. I want to add the information to the peak GPU memory info. I want to say that the GPU I, so formatted string, GPU I, peak usage in gigabytes is going to be set to be equal to torch CUDA max memory allocated divided by 1E9. So we're going to get bytes and we want to have gigabytes. All right. And finally, what we want to do is we want to return the object. We're going to return a dictionary. And we're going to say that the GPU count is, or actually I need to have this as a string. GPU count is going to be equal to number of GPUs. In this case, it's going to be 1. Then we're going to say peak GPU memory usage GB. That is going to be equal to peak GPU memory info. And then the generated image is going to be equal to the image string. That is basically the code for our endpoint. Now, to take that and deploy it to our account is quite simple. I have the app now. I'm in my environment. All I have to do is I have to say beam deploy and then app.py : handler. That selects the function. This is going to deploy it as a serverless endpoint. I can just run this. So it's going to build the image and it's going to deploy the container. Now, I need to clear the screen here because we can see my token. So I'm going to get rid of that for a second. So I cleared the screen, but I wanted to show you the structure of the request. We have the endpoint, we have the connection type, the authorization. I think I deleted something here. It's authorization, bearer, and then the token. Now I removed the token, but here you can find your token. And this is important because now what we're going to do is we're going to send a request to that endpoint, but for this, we're going to write our own Python script. So instead of just using this curl command, we're going to write our own Python script. For that, I'm going to terminate here. I'm going to open up a new file, sender.py, sender in terms of request sender. And we're going to do the following. We're going to import requests. This is now something that will run locally. So if you want to use this, you need to pip or pip3 install requests. You also want to install pillow because we're going to say from pill import image. So for that, pip or pip3 install pillow. And above that, we also want to do import base64. In this case now really for the decoding. And we also want to do same as before, from IO import bytes.io. So we have these 4 packages, 4 imports. And now we're going to just model the curl command that we had from before. So we're going to say URL is equal to whatever the URL was in the output. Then we're going to say headers is equal, and we're going to set this equal to a dictionary. The important thing here is that we specify the authorization field. So we're going to say authorization, and then this is going to be equal to bearer and the token. I'm going to set this after I'm done with the coding. So I'm going to do this off screen, but here you want to enter your own token that you had from the settings. So your API key basically. And then we also want to specify content type is application/JSON. These are the headers. And then the payload is going to contain our prompt. So the payload is also a dictionary, and it's going to have the field prompt. And this is just going to give us, I don't know, a dog playing at the beach. That is going to be our generation prompt. And what we want to do now is we want to send that request, and we're going to get a response as a result of that. Requests.post URL headers equals headers and JSON equals payload. That is going to send a request to our serverless endpoint. And as a result of that, if everything goes well, we're going to get the image. So we're going to say if the response dot status code is equal to 200, which means success, then we're going to get the data from the response. So response.json, I think I just imported regular expressions, so let's get rid of that. Data is equal to response.json, and then the image data itself is going to be base64 .b64 decode this time from the JSON object, the generated image. And the image itself is going to be image from pillow open, and we want to open bytes.io of image data. So that's going to be the byte stream. We open it, and then we save that image finally to our disk generated.png. We also want to print the information about the GPU, so about the GPU numbers or the GPU count, and also the GPU memory used. So GPU count is going to be equal, or it's going to be shown based on data GPU count. And then the second thing is memory usage in gigabytes. That's going to be peak GPU memory usage GB. And finally, we also want to do image show, just so we get the output immediately when we run the script. And otherwise, we want to print that something went wrong. We want to say that there was an error, and that error is going to be, first of all, described as the response code, so status code, and also what the text is, so response.text. Perfect. So that is our script. I'm going to modify this now briefly by adding the token and adding the URL from the output in the command line, and then we're going to run that. Oh, there's one problem here. We need to, of course, use double quotations if we use, at least in older Python versions, if we use single quotations on the outside. So I'm going to just replace this since I'm still using Python 3.10. And now we're going to run this. We don't have a module pill, so I probably need to install pillow and requests here in this environment, and then it should be possible to run this. Okay, so I see that I have a problem with my handler. For this, I'm going to open up my app. And the problem is I made a mistake. We don't just say stable diffusion XL pipeline. We, of course, need to say that we want to use a pre-trained model. This is why we're specifying even the path here. So we need to say from_pre-trained. That's important. Now what we need to do is we need to run this again. So we need to say beam deploy app.py, and then handler. I'm gonna again get rid of the output, but one thing that you need to notice is every time you redeploy this, you're going to get almost the same URL, but the version is going to change. So make sure you also change the URL in sender.py. You don't just redeploy and use the same sender script. You always have to update the version in the URL. And of course, another thing that's super important to do is we need to send the pipeline to CUDA, so to the GPU. Otherwise, it's going to use the CPU, which we of course don't want. The reason I forgot this is because we're going to do this differently when we have two GPUs. We're going to provide a different parameter here. But for now, since we're using one GPU, we're going to just say to CUDA to send it to the GPU. What we need to do is, again, beam deploy app py handler. By the way, one thing that you can do in the dashboard in Beam is you can go to deployments. I'm going to show you that. You go to deployments, you go to the endpoint that you're using, and you can see here the status of your operation. You can also see what's happening here in terms of CPU utilization, memory, and GPU memory. You can also see what's happening exactly here. So how it's working on that, and what kind of system resources it is using, so you can track what is happening here, and in the case of GPUs also how much memory they use. So now I received the output, a 512 by 512 pixels image. Now what I think is a little bit interesting is that we don't get the prompt that we asked for. But of course this makes a lot of sense because we're still using the string from before. We of course need to say prompt here. Otherwise, it doesn't make sense. So now we need to do one more deployment, beam deploy app py handler, and update also again the version number in sender. So you can see how the memory is being allocated. It's working right now. And there you go. We have a dog at the beach, which is exactly what our prompt was. But you can see we're already using 9 gigabytes. If I try to do this with a 2048 by 2048 image, it's not going to work on a single GPU. I'm not going to try it now. Just trust me on that. It's not going to be enough. And because of that, we're going to use 2 GPUs now. So I'm going to move this back to my second screen. I'm going to go to the handler, so to the app py handler. And the only thing that we're going to change here now is we're going to say that the GPU count is going to be equal to 2. And instead of sending this to CUDA, what we're going to do is we're going to provide the parameter device map equals balanced. This basically means use all the GPUs if necessary. So just spread it, balance it across the multiple accelerator devices that you have. And this alone will allow us to use 2 A10G GPUs, so a total of 48 gigabytes. And that's going to be enough to run the prompt even with 2048 and 2048 here. So I'm going to do this again. I'm going to say again, beam deploy app.py handler, and again, change the version in the URL accordingly in sender. So let's give it a try. Python 3 sender py. And in this case now we can already see that we have GPU memory, which is combined here. We have 44 times 98 gigabytes, even though we have 2 GPUs. It's listed as one amount here as one amount of total VRAM that we have on both GPUs. So now you can see the GPUs start allocating memory. Probably we're going to go beyond the 24. I'm not sure if it's going to be displayed here. It's going to definitely be displayed when our sender is done with the work, when our sender receives the information. Okay, so we got the image. It's 2 dogs kind of, and whatever that is on the beach. So the image is fine. The GPU memory that we have here now is 23.78 gigabytes, but let's see what our output says. Our output says that we have 2 GPUs, and the one GPU had 22.719 gigabytes of peak usage, and the other one, even though it wasn't used a lot, it was used 1.6 gigabytes of peak usage at GPU 1. So both GPUs were utilized. Probably we can go even higher resolution than that, but this is how you can combine the VRAM of 2 GPUs to run a machine learning model and to generate images with a pretty high resolution, which would not be possible on a single GPU. We can even increase that. This is how that works. So to summarize again, on Beam, you can get free credits. You get 15 hours of compute, free trial credits without having to sign up with a credit card or anything like that. You can easily just do what I did in this video today. You can deploy your Python scripts, CPU, GPU, multiple GPUs. I think you need to request the multiple GPUs, it says in the documentation. But besides that, you can run all of this here on Beam. Again, they're sponsoring this video, so it would also help out the channel if you check them out in the description down below. Free compute and helping Neural 9. What's better than that? I hope you enjoyed that. That's it for today. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And as already mentioned, it would help out the channel if you check out the sponsor of this video today, Beam. The links are in the description down below. No cost, free credits to work with GPUs or CPUs in the cloud. And besides that, of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.